Hi, fourth grade. Welcome back to your math lessons. Today we're going to wrap up chapter 23 by focusing on lesson 9, relate perimeter and area. For this lesson, you'll need to have out your textbook, turn to page 616, and your math journal. Please get your journal labeled and then we can get started. For this lesson, we're going to be relating perimeter and area and discovering more about how these two different math concepts work together, how they are different, and how they are related. Before we begin on the new part of our lesson, let's review these definitions for perimeter and area. Perimeter is the distance around the edge of a shape. We find this by adding up all of the sides of the figure. The area is the amount of space inside a shape. We find this by multiplying the width of the shape by the height of the shape when we're working with squares and rectangles. Remember, the area of other figures use different formulas. One way that you're going to see us calculate the perimeter and area today is by counting the number of squares we see. Sometimes we'll see units measured out like 6 inches and 3 inches, or sometimes we'll just see squares. So just know if you ever see a square, one side of the square is 1 unit and a whole square is a square unit. Let's get started. We're going to relate perimeter and area and see how shapes that have the same perimeter can have very different areas, or shapes that have the same areas can have very different perimeters. Let's take a look. Here's a problem to get us started. Mr. Foster is framing 3 pictures. Does he need the same amount of framing for each picture? That's question 1. Does he need the same number of square inches of glass for each picture? To find how much framing Mr. Foster needs, find the perimeter of each picture. To find how much glass he needs, find the area of each picture. So let's take a look. 3 very different pictures, different shapes, different sizes. Let's see what they need for the perimeter by adding together the sides of the shapes. Let's start with the big long rectangle. Go ahead and draw this in your journal. We have the first picture frame, which is 3 inches by 7 inches. Although it does not give me the measurements for the other sides, I know that rectangles have 2 pairs of equal sides. So I know that the other sides are also 7 inches and 3 inches. Let's add this together to find the perimeter. The perimeter will equal 3 plus 3 plus 7 plus 7. The perimeter of this first picture is 20 inches. Let's find now the perimeter of the next figure. Which is 6 inches by 5 inches. I know that the opposite sides are equal. The perimeter of this figure is equal to 6 plus 6 plus 5 plus 5. For this picture, for picture B, we have 6 plus 6, which is 12. 5 plus 5 is 10. 12 and 10 makes 22. So for picture B, we have a perimeter of 22 inches. So it looks like so far he does need different amounts of framing for the pictures. Let's measure out picture C, which is in the shape of a square. And that means that all of the sides are equal. This is 5 inches by 5 inches by 5 inches. The perimeter for the square will be the side length times 4, or 5 plus 5 plus 5 plus 5. I'm going to do the side length 5 times 4 to shorten my work. The perimeter will equal 20 inches. So I see that in both figure A and figure C, oh, I'm so sorry. I did that no, I did that correct. I see that in figure A and C, the perimeter of those figures are the same. However, in figure B, the perimeter is different. Now let's check out the area. The area for figure A is going to be the width times the height. So we have 7 inches times 3 inches. The area equals 21 inches squared. Let's try out figure B now. The area will be the same formula, the width times the height. So we have 6 times 5 inches. 6 times 5 equals 30 inches squared. So again, we have a different area for figure B. Let's take a look now at figure C. The area will also be the width times the height. So we have 5 times 5. The area of figure C is 25 inches squared. So for all of these figures, they all have different areas. Although figure A and C had the same perimeter, they have different areas. Here's our key math concept for today. Two figures can have the same area but different perimeters, or different areas but the same perimeter. This is because of our formulas for perimeter and area. Let's focus first by reviewing what those are. The formula for perimeter is all of the side lengths added together. So side A plus side B plus side C plus side D, and so on depending on the side lengths. The perimeter for area is area equals the width of the figure times the height of the figure. This is for rectangles and squares only, which is all that we are working with today. We're going to put this into practice by comparing areas and perimeters. Let's start with number 1. Number 1 asks, how can you change this rectangle so that it has the same perimeter but a greater area? Model, then record. So right now we have a rectangle that is 6 inches by 2 inches. The perimeter for this figure would be 6 plus 6 plus 2 plus 2. The perimeter right now is a total of 16 inches. Oh, I'm sorry, not inches, centimeters, 16 centimeters. So for this problem, we want to create a figure that has the same perimeter. So that means all the way around the side lengths need to equal a total of 16 centimeters, but we need it to have a greater area. So before we do that, let's find the total area. Now, because this is broken into squares, even more simple than multiplying, we can count the squares. So I see 2, 4, 6, 8, 10, 12 squares. So the area is equal to 12 centimeters squared. Another way that we could do this is by showing 6 times 2, which is also equal to 12. The width times the height. So we need to build a larger rectangle that has the same perimeter but a bigger area. So let's take a look. If we build out a rectangle that is longer and thinner, let's see if that will help us have a larger area. So I'm going to, instead of doing it 6 centimeters by 2, I'm going to try it Try making a rectangle that instead has 1 by 16. Let's try that. So if it was 1 by 16, oh, the perimeter would not be the same. Okay, I'll have to do this a little bit differently. I need the total to be 16. So I can't have 16 across the top, but I could do something smaller. So I have to have at least one square on each side. So I'll leave the heights one square. Let's try doing so if I do this, that will give me 7 plus 7 plus 1 plus 1, which would equal a total of 16 centimeters. My perimeter would be the same, but when I'd multiply the area, that would only be 7 centimeters squared. So that is not going to work. Let's try something different. So making it longer and skinnier did not work. Let me try making it a larger rectangle that's a little bit wider. So instead, let's even try, what if we make this into a square? So I'll make each side be 4 centimeters long. I know that 4 times 4 is 16. So I know that for my perimeter, if I do 4 plus 4 plus 4 plus 4, I know that my perimeter will still equal 16 centimeters, so I'm on track for that. And my area equals the width times the height, which is 4 times 4. The area also equals 16, but it's 16 centimeters squared. This is larger than our original 12, so I have solved that problem. I made it into a square instead of a rectangle, and that provided a greater amount of area. Now, when you're solving these problems on your own, it's okay if the first thing you try doesn't work out, just like I did. Sometimes you have to try multiple things to get it to work out. Just make sure that you remember that the perimeter is the distance around the figure, and the area is the space inside. Make sure you have those vocabulary straight as you solve your work today. Let's do a few more problems. We're going to find the perimeter and area of each figure. Then we'll draw another figure that has the same perimeter, but a different area. Let's take a look at number 2. I have a rectangle that is 6 meters by 3 meters. The perimeter for this figure is going to equal 6 plus 6 plus 3 plus 3. 6 plus 6 is 12, plus 3 is 15, plus another 3 is 18. So I have 18 meters for my perimeter. Now let's solve the area. The area equals the height times the width, which is 3 times 6. The area, 3 times 6, is also 18, but it's 18 meters squared. So I need to draw a figure that has the same perimeter, but a different area. So I'm going to try this out. I know other ways to make 18 is 9 and 2, but that will be too big. So what if I do instead, I'm going to make one of my sides 4. So I'll make this side 4. That other side will be 4. So I have a total of 8 so far. I need 18 meters across for the perimeter. So that means I have 10 meters left. So that means I have 5 and 5 left. So just to show you that that equals the same thing, the perimeter is 4 plus 4 plus 5 plus 5. 4 plus 4 is 8, and 5 plus 5 is 10. So the perimeter, 8 plus 10, is 18 meters. So I've done that. So far, I've kept the perimeter the same. The area, let's see if the area is different. Area equals height times width, which is 4 times 5. The area, 4 times 5 equals 20 meters squared. So my area is different, just like the directions say. So that means that I am good to go. It is helpful when they tell you it doesn't have to be bigger or smaller. If it just has to be different, that gives you a little bit more freedom to play around. Let's try it in the reverse way with number 5. I have this square here, which is 4 meters all the way around. For this one, we're going to find the area and perimeter and then draw another figure that has the same area but a different perimeter. So this time we're looking for the same area. That means that when we think of the factors for the number, they need to be factors that will equal the same as the area we get. So let's take a look. The perimeter here would be 4 plus 4 plus 4 plus 4 all the way around. All sides are equal to 4 meters. The perimeter equals 16 meters. The area for this square would be 4 times 4, the width times the height. The area is equal to 16 meters squared. So now I need to design another shape that has the same perimeter, the same area, but a different perimeter. So I know different ways to make the number 16 is 8 times 2. So I'm going to use those for my side lengths of my figure. So instead of a square, I'm going to make a rectangle with 8 times 2 for the area. The area of this figure would be equal to 8 times 2 because the width times the height. 8 times 2 is 16. So I have 16 meters squared, just like in my first problem. So I've solved that part. I've kept the area the same. Let's make sure the perimeter is different than 16. So I have 8 plus 8 plus 2 plus 2. 8 plus 8 is 16. 2 plus 2 is 4. 16 plus 4 is 20 meters. So I've made my perimeter different. So what I did for these, just so you know what to think when you solve them on your own, is I thought of different ways. If we're wanting to keep the area the same, we need to think of other factors that equal that. So if we want the area the same, go ahead and write this down in your notes as well. We want to think of other ways to multiply to get that answer. So think of other factors that equal that area. If we want to keep the perimeter the same, so go ahead and add this into your notes. If we want the perimeter to be the same, what we need to think of is what times 2 plus what times 2 is going to equal the same perimeter. Also, just playing around and guessing and checking is a great idea as well. So I encourage you to try that also. All right, we're going to now compare a couple figures and see which ones have the same area but different perimeters, or the same perimeters but different areas. Let's take a look at number 15. We're going to use figures A, B, C, and D to answer these questions. For number 15, it asks which figures have the same area but different perimeters. So first, for starters, before we get going, let's start by counting the area for all of these figures. Now, these are not squares, so I cannot multiply the width times the height to get it unless I split these all into individual rectangles and squares, which would take a very long time. So I'm going to use the tools they gave me, which is the actual squares laid out. So these, instead of being in centimeters or inches or meters, these are just going to be in what's called a unit. Because I don't know what the actual measurement is, but they're split into equal squares. These squares are going to be called units. The side lengths will be units, and the area will be units squared, or square units. So let's get started by counting. For A, I see 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So I know that A is 20 units squared for the area. For B, I see 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25, and 26. So for B, it's 26 units squared is the area. C, I see 2, 4, 6, 8, 10, 12, 14, 16, 18, and 19. So C is 19 units squared is the area. And for D, I see 2, 4, 6, 8, 10, 12, 14, 16, 17, 18, 19, and 20. 20 units squared. You can count them in any way you'd like. I like skip counting by twos, and I do have the ability to draw on my pictures. You don't, so if you need to go a little bit slower to count, that's fine. So I've now found the different areas. I will need to locate the perimeters, but we'll see if we can get away without having to count all of them for right now. So number 15 asks which figures have the same area but different perimeters. So far I know that A and D have the same area, which is the first part of that, but different perimeters. So 20 units squared and 20 units squared. I don't see any other ones with the same area, so I assume that's the answer, but let's count the perimeter just to be safe. So I'm going to use green to show you how I'm going to do that. I'm just going to count all the way around the figure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So the perimeter is 22 units for A. Let's figure out it for D. I'm counting each side length, not squares this time. I'm counting each side length because the perimeter is the distance all the way around the figure. So I got to get all of those side lengths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Wow, much bigger perimeter. 36 units for D. So my correct answers for number 15 are A and D. Have the same area but different perimeters. Let's take a look at number 16. Number 16 asks which figures have the same perimeter but different areas. So I assume that's going to be B because they have different areas. Let's count the perimeters just to be sure. Again, I'll pull out my green and I'm counting the side lengths around the entire figure, every nook and cranny. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to pause here to show you to make sure. Do you see how that inner space here has 3 side lengths? So you want to make sure that you don't miss out any of those. We want to catch them all. So I'm at 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 units. And it's important to also write them down. So when you do this independently, make sure that you are writing that down on your work page. I definitely encourage you to draw on top of the drawing when you can so that you're not losing track of where you are. That would be a very easy way to mess up. All right, and then figure C, I'll count the perimeter on that. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 units of the perimeter. So number 16, which figure has the same perimeter but different areas? That would be not B and C. Which figures have the same perimeter but different areas? So the perimeters here, 36 and 22, those are not the same. So my prediction was wrong. That's why it's so important to make sure that you actually solve out every one. So the ones that have the same perimeter I see are C and A. Both have perimeters of 22 units, but they have different areas. So my correct answers for this one is A and C have the same perimeter, 22 units, but different areas. All right, it's going to be your turn now to practice independently. So I want you to take out 23.9 PW. You're going to be solving all of it today. On numbers 1 through 3, you get to draw your own. So if you want to ask me questions about that at Zoom on Wednesday, I'd be happy to answer those for you. Just make sure that you're reading the directions very clearly about whether it should be same perimeter or same area. For 1 through 3, it does say you need something with the same perimeter but a different area. So keep that in mind. Make sure that you remember perimeter, you need to add up all 4 sides, not just 2. And then at the bottom here, make sure you also read carefully about whether it's same or different area or perimeter. So good luck. If you need help, please reach out over Class Dojo. I would be happy to help you. Otherwise, I will see you Wednesday for our Zoom meeting.